This is DANL 100, Programming for Data Analytics, Chapter 18, Python Loops and Conditions. Agenda. In this short video, I'll discuss the following topics. Topic number 1, for loop and while loop. I'm going to compare R with Python. Topic number 2, double for loop. Topic number 3, Python download module. So the name of the module is called download. Topic number 4, using a double for loop to download all the SEC quarterly index file, zip file. Topic number 5, logic AND, logic OR, and logic NO. Topic number 1, simple for loop. First, so let's look at R. How can we write a for loop in R? I'm going to launch Notepad. Suppose our intention is print value from 1 to 10. For a for loop, for I in 1 to 10. Then we print I. Okay, so this is the simplest for loop. So let's print it. Okay, so for I in a data set from 1, 2, 3 up to 10. So we print I. So this is a simple for loop using R. Okay, so let's go to Spider. So let's look at the Python code. For I in range. Okay, I'm going to make it bigger. Okay, for in range, so 1, 10. Suppose, so let's look at the 10. Print I. Okay, so this looks almost identical, right, to the previous one. So let's run it. Okay, you will see from 1, 2, 3 up to 9. Okay, so we have one value is missing. Suppose we use 11, and then when we run it, on the right hand side, you will see 1, 2, 3, 4 up to 10. So this is, suppose it's for N1 to N2, so the last N2 will not show. Okay, so this is the simplest one. So let's go back to Python. Sorry, let's go back to R. Okay, so usually I add this one, curly bracket, and curly bracket. Okay, and so this is more code here. Okay, so this is more code here. Okay, and again, I can copy paste, and there's no difference in terms of output. Okay, so this curly bracket and this a pair of curly bracket indicate all the line within this pair of curly bracket belong to this for loop. Okay, and so this is also true for the Python. Okay, so we can like more code here. Okay, so actually anything alignment after colon, so we have alignment, and alignment more here. Okay, so this all these line below belong to this for loop. Okay, belong to this for loop. Okay, okay, so let's look at while loop. Okay, so usually for while loop we have three components. So usually is we assign an initial value. Okay, while I is less than 10. Okay, it's less than 10, then we print I. Okay, we print I. Okay, the third component is missing. I'm going to show what is the consequence. Okay, so the first condition is we issue an initial value called we assign 1 to I, while, so this is condition. If this condition is satisfied, we print I. If it's not, we don't do it, we stop. So this is called a while loop. Okay, so let's copy and paste. We are going to enter an infinite loop. Okay, so this is, so paste. Okay, you see that this is it's still running, and so we have to stop it. So we have to stop it. If we enter infinite loop, the reason is, so this condition never satisfied. Okay, sorry, it's always satisfied. It's never violated. Okay, so this is missing. Suppose I equals I plus 1. Okay, and I repeat. Okay, so this is for the while loop. Usually we have three. We have three important. Of course, here we have some more code here. Some more code here. Okay, for the while loop, we have three components. Usually we have an initial value, and we have a condition, and we increase our intermediate value I by some value. Okay, so objective of this one makes this condition sometimes is not satisfied. Okay, so let's copy and paste and write. Okay, okay, so 1 is missing, so we should less than or equal 10. So we have initial value, we have a condition, we increase the intermediate value by 1. Okay, then we have the same result compared with a for loop. Okay, so let's go to Python. Okay, so let's use a new one. Okay, so again we have initial value. Okay, while I is less than 10, so we have a colon. Okay, print. Okay, print. Okay, for the Python we have I plus equals 1. Okay, so this is equivalent to I equals I plus 1. Okay, so this is, I repeat, okay, we have three, for a while loop, usually we have three most important components. Okay, the first one, we have assigned initial value, then we have a condition, and also we increase or decrease our value. Okay, so let's run it. Okay, you see we have 1, 2, 3 up to 10. Okay, so this is also true. So this is equivalent to I equals I plus 1. Suppose we use times. Okay, I star or multiplication. I multiplication equal 1. So this is equivalent. So let's times 2. Okay, cannot always times 1. Okay, so this is equivalent to 2 times I. So this is I equals I times 2. I equals I times 2. Okay, I equals I times 2. So let's run it. Okay, so I take the first value is 1, double, then becomes 2. Okay, 2 times 2, double, then 4, and after A, because A double becomes 16. 16 is larger than 10, then we stop. Okay, so this is a special way to increase. We have certain values. Okay, it is also useful for division. Suppose let's it's less than 10. Division is also true. Suppose we have 100, and this is always divided by 2. Okay, divided by 2. So let's make it larger than or equal 10. Okay, so let's run it. So it's divided by 2, divided by 2, divided by 2 all the time. Okay, so let's run it. Okay, the first value is 100. So 100 divided by 2 is 50. So 50, this condition is satisfied. Then 50, 25, 12, 12.5. 12.5 divided by 2 is less than 10. So this condition is violated. Then we stop. Okay, so let's look at another. So I'm going to copy, paste, put it here. Okay, so this is another while loop. Okay, so this is, suppose we use 2 equals 2. So this is always true. Okay, this is always true. Okay, so this is if I is larger than 10, and we stop. Okay, we break. Okay, so this is 2 equal 2. So actually this is we always run this while loop. Okay, and we print I, we increase I by 1 value. However, we have a condition. Okay, and for the previous condition is here. Okay, now within the function, within the loop, we have the condition. So if I is larger than 10, we break. Okay, we break. We break the loop. Okay, so this is, and we're going to run it. Okay, and we have the same result. We print 1, 2, 3 up to 10. Okay, so let's look at the Python. Okay, so let's look at the Python. Okay, same thing. We assign I with the initial value. Okay, I think the 2 equals 2. Okay, so print I. So I plus equals 1. So we increase I by 1 value. So if I is larger than 10, we break. And more code here. Okay, I'm trying to compare R with Python. Okay, if suppose we have enough knowledge about R, then you can easily just borrow, just copy, and with a small modification. Okay, so again we have 3 components. So this is initial value, and for here we increase I by 1, and we have a condition. So after this condition is satisfied, then we stop. Okay, so let's run it. Then on the right hand side, you will see 1, 2, 3 up to 10. So this is if break. If condition satisfied, then we break. Okay, so let's go back to R. Okay, so let's look at another variation. Okay, suppose we have I equals 10, we have A. So A equals, so A. So let's use A, and A equals 0. Okay, so this is another sort of variation. Okay, so if we look at here, and so let's go to R. Okay, so A, so 2 equals 2. So actually this is true. Okay, this is true. Suppose we I equals 1. I less than or equal to 10. And so actually our for loop, while loop, and the result is true or false. Okay, true or false. Okay, because A, so A, suppose A equals 4. Okay, so A equals 4, because the 4 here is true. If A is 0, then it's false. Okay, so this one is equivalent to previous one. Okay, so let's copy, paste, and so let's run it. Okay, we still get 1, 2, 3 up to 10. Why? Because if I is 11, A is 0. So A is 0, while, so this is false, then we stop. Okay, so let's go back to Python. Okay, so let's look at equivalent Python code. Okay, and again, we have initial value, I equals 1. Okay, and so let's use 2. So let's use 2 while A. Okay, I'm going to colon. The alignment is very, very important. Okay, so this is I plus equals 1. Okay. So if I is larger than 10, and we assign 0 to 8. Okay, so this is equivalent if compared with R. Okay, we have initial value, we just assign a non-zero. Okay, suppose this is 200, and so A equals 200, while A, so if A is 0, we stop. We print I, we increase I value by 1. If I is larger than 10, we assign 0 to 8. Then this while will stop. Okay. Then you will see from 1 to exact same thing compared with the R code. Next, we look at the double for loop. Okay, let's go to Notepad. Okay, so this is one layer. So make it easier, I use from 1 to 4. So this is for I, and we have another layer. Okay, so this is for J in 1 to 3. So make it easier, and curly bracket and curly bracket. Okay, for the R, indentation is not important. However, just make it easy. So K equals 2 times I plus J. Then we print K. So this is for double loop. Okay, so this is curly bracket corresponding to this one. Okay, the first layer, and the second one is from here and to here. So this is our major part, major code. Okay, so I from 1 to 4, J from 1 to 3, and we generate a variable called K, 2 times I plus J. Okay, so let's copy and paste. Okay, so this is, so let's look at the first one. So I take a value of 1, and 2 times 1 equals 2. Okay, and J plus J is 1. So the first one is 3. So let's look at the last one. Okay, so I take value of 4. So 2 times 4 is 8. J take a value of 3. So A plus 3 is 11. So we got this one. Okay, so let's go to Python Spider. Okay, so I paste it here. Okay, and so I in range. Okay, remember, and we lost 1, so we use 1 to 5. Okay, so this should be 5. Okay, and we have a second for loop, J range 1 4, and colon. Okay, then we enter. So the purpose is we want alignment. Okay, so print, then nothing below. Okay, so this looks much simpler. Okay, so for I in the range from 1 to 5, 5 because 1 is missing, and for J in the range 1 to 4, colon, and alignment, K equals 2 times I plus J, then print K. So let's run it. So we have the first number 11. So first number is 3. I take a value of 1. So 2 times 1 equals 1 plus 1 equals 3. So last one is 3. So look at the last one. Okay, I equals 4 because 1 is missing. So 4 times 2 is A. J last value is 3. So A plus 3 is 11. So we got this same result as 11. So this is a so-called double for loop. and for the in-class exercise to download all the SEC quarterly index zip file, we are going to use similar double for loop. Topic number 3, Python download module. Okay, we are going to use the download Python module to download the SEC index file. Okay, so let's import from download, import download. So actually the first download is a module, the second download is a function. Okay, so no module named download. So this indicates we need to install it. Okay, so on the counter, no module names download. This indicates we need to install the Python module called download. Okay, so let's go to on the counter prompt. Okay, we simply issue pip install download. Okay, the last sentence is successfully installed. Okay, so let's go back here. So import and download. Okay, so import download. We are going to write this function, please. Okay, and the first one is, so let's test it. Okay, in file equals, so http data yyy.com. So data, so let's ff3 monthly. Okay, let's use CSV and IBM daily CSV. So this is, suppose we want to download the out file. Suppose let's call it ttt CSV. You can use any name. So download and in file out file. Okay, so this function is quite so from download, so module, we import download. So download is function. Okay, we have in file IBM daily CSV, and we have out file, we use any name. So download the in file out file. So let's run it. Okay, and you see here we download it successfully. Okay, so next one we are going to download all the zip file from SEC filing. Okay, and as the last topic, we are going to download all the SEC filing zip index file from 1993 to 2020, or even the first quarter of 2021. Okay, first, so let's as a first step, so let's look at the link. Okay, so this is .search web. Okay, type SEC. Okay, and actually you can Google SEC quarterly index. So we are going to use this one. Okay, so this is, so let's go back to Python, and so this is pass equal. Okay, paste it. Okay, so this is SEC. You can type use keywords SEC for index. So let's find the setting of this one. Okay, so I paste it, and so this is US Security and Exchange Commission. So this is index file. Okay, and so let's go to, suppose we choose 2020. Okay, we choose QTR1. Okay, so if you look at the, here is 2020 QTR1. So 2020 is year, QTR1 is first quarter. So we are going to download the company.zip. Okay, so this is, I call the step 1. So step 1, we simply called my file. So this is, I know it's 2020 QTR1. So this is ny.zip. Okay, so this is eventually we are going to, so this is usually I call the step 1. Okay, so import pandas as PD. I don't think we need pandas. Okay, from download, import download. Okay, so from import download. Okay, so this is path. So in file equals path plus my file. Okay, download in file out file. Okay, and so usually this is I call the step 1. So step 1, we simply trying to manually to download. Okay, download, and we download the specific one. So let's try this one. Okay. So my file plus my file 2020 path unsupport type string and string path my file. Oh, so this is equal. Okay, so this is wrong. Okay, so this is okay, so let's look at the in file. Okay, so this is in file, and so let's try to manually download this one. Okay, so manually download, I treat as a first step or step 0. So next step we use download function. Okay, so let's go to here and we paste. So let's choose another one. So we paste it and we download. Okay, on the left hand side we see this is a valid link. So valid link. So let's go back to Python. Okay, so let's run it. Let's download it. Okay. Oh, we don't have output file. So let's use out file equals, and so this is index 2020 q1.zip. Okay, suppose we manually, eventually we are going to change it. Okay, index 2020 q1.zip. Okay, so let's run it. Okay, you see we download it. Okay, so if we use import os list dir, okay, then we'll see where's our index. So this is our index 2020 q1.zip. Okay, so let's try download this one another time, second time. Okay, and so this will give, so replace is false and the data exists, so doing nothing, use replace equal true. So let's copy this part. Okay, so from here you will see here replace equals false. So this indicates when we download a file, if a file with the same name, and then the software will do nothing. Okay, suppose we use replace equal choose, then we are going to replace existing file. Okay, so this is I treat as the first step. Okay, and we manually we have an in file, and we name it out file, and we download it. Okay, so as the second step, okay, I'm going to, so I treat as the first step. So let's look at the second step. Okay, so this is second step. I add y equals 2020, q equals 1. So basic idea is we want, okay, so let's use 2. Okay, we use 2. And so we want replace 2020 with y. And we want replace this one with q. Okay, so actually 2020, so let's use y plus, okay, we delete 2020, okay, because this y is equivalent to 2020. Okay, so we replace this one with q. Then plus, okay, so this is, if you look at here, okay, we replace 2020 with y, we add plus signs, we replace 1 with q, we add plus signs, okay, and similarly, we index we have to plus year, okay, plus and Q and plus Q plus zip. Okay, so this is only modification. Okay, so let's look at this one. Okay, so let's hit F9, and there are some issue. Okay, so this is the reason is y is an integer. Okay, y is integer, and q also integer. Okay, as I showed before, we should use str. We use convert a string. Okay, so I'm going to show here. Suppose string 100. Okay, so this is 100 is integer, and then it becomes a string. Okay, so string y and string q. So this will convert integer to a string. So this is out file is true. String y and string q. Okay, so this is string y and string q. Okay. Again, so this is first step. First step, we manually we have input file, we have output file. Okay. Step 2, and we have two variables, y equal 2020, q equals 2. Okay. So let's run it. And you see, we download 2020 q2. Okay. Then we can use os list dir. Okay. Then we can find, yes, we got this 2020 Q1, 2020 Q2. Okay. Okay, so this is called step 2. So let's look at the step 3. Okay, so I called step 3. Step 3 is simply Step 3, we generate a loop, okay, for q in range 1 to 5. Okay, so let's make 2019. Okay. So Q in range, remember? Q1, Q2, Q3, Q4, because one is missing. Okay, we're going to run it. Then we successfully download 2019 Q1, 2019 Q2, and 2019 Q3 and 2019 Q4. Okay. So as a last step, we simply write a loop. So let's go back to the here. And you see the starting year is 1993. The ending year is 2021 and the first quarter. Okay, so actually as the last step and a double loop. Okay, so this is for y in range 1993, 2021. Okay, so this is y in range 1993, 2021, and again alignment. Okay, so this is the final one. the final one is we have a path. We have two variables. One is called y, and another is called q. Okay, y from 1993 to 2020. We add 1, so it's 2021. And q is from 1 to 4. We add 1, it's from 1 to 5. Okay, so as an illustration, so let's try and download 1 year. Okay, so this one will not working. Okay, so I just want to show you. Okay, so 1991. So I'm going to run this part. Okay, you will see it's not working. Okay, the reason is because this one. So let's use 1994. Okay, then we can run it. So this is 1993, 1990, Q1, Q2, Q3, and Q4. Okay, I repeat. Okay, so this is I'm going to make it smaller. Okay, I treat this one as like 3-step approach. The first one is we hard code. We have an in file. We have in file. We have an output file. Okay, so we download. We test our code. We test our path, and everything's fine. Okay, then we hard code. Use we randomly choose 1 year and randomly choose 1 quarter, and we're trying to download. Okay, the next step, and we use 1 loop for the queue, and after everything's fine, eventually we have 2 for loop. Then we download all the zip file from SEC's Edgar quarterly indices. It's about the logic and logic or and the logic no. Okay, so let's look at R. Okay, I always compare between R and Python. Okay, so let's. Okay, so A equals 10. Okay, so B. So let's assign some value. Okay, A equals 10. We assign 10. B equals 20. Okay, if A and B, if A is larger than 0 and B larger than 0, and we type, so we print both are positive. Okay, so this is, so let's make it complete. Else, okay, else we print at least 1 is 0 or negative. Okay, so this is we have 2 conditions. So we have A value, we have B value. So this is a logic AND. So this is logic AND. So this is logic AND. So we use ampersand. So A is larger than 0 and B is larger than 0. Both are positive, and otherwise at least 1 is not positive or 0 or negative. Okay, so let's copy and paste. Let's run it. Okay, and we know because A is 10, B is 20, so both are positive. Okay, so let's make it negative 9. Okay, so B is negative 9, and then we run it. Okay, then we'll have the second. So at least 1 is 0 and negative. Okay, so let's look at the corresponding Python code. Okay, so I'm copy and paste. Okay, so A equals 10. So B equals 9. Okay, so this is if A. So this is for Python is easy. It's AND. Okay, it's AND, and we print else. Okay, colon. and we print. Okay, so this is quite similar compared with R. Okay, and so we have a value, we assign A, we assign a value to A, we assign value to B. So A, if A is larger than 0, and so this is logic and B is larger than 0, we print both are positive, otherwise at least one is 0. Okay, right? So both are positive. Okay, so let's assume B equals 0. Then at least one is 0 or negative. Okay, so this is logic AND. Okay, so let's look at logic OR. Okay, so this is logic AND, and so we still use AND B. Okay, so this is logic OR. Okay, so this is if A larger than 0, or so this is vertical line is for the logic OR. Okay, so this is logic OR. Okay, so I'm going to switch these two. I'm going to copy this one. So at least one is positive. Okay, so this is at least one is positive. Okay, so both are positive. Okay, so this is both are positive. Okay, at least one is positive. Okay, so A larger than 0 or B larger than 0. Okay, so let's write. Okay, at least one is positive. Okay, so let's make both are positive. Positive 10, positive 9. So let's run it. Positive 1. Okay, still positive 1. A or B at least positive. Okay, both are negative. Okay, sorry, this is both are negative. Okay, so this is both are negative. So let's look at the special case. This is negative or negative 10 and negative 9. Okay, so at least one is positive. The opposite of this one are both are negative. Okay, so this is going back here. So both are negative. Okay, so let's look at equivalent Python code. Okay, so let's make a new file. Okay, so this is logic OR. Okay, so logic OR. Suppose A is positive, B is negative. Okay, so this is logic OR. If A is positive, OR. So this is beauty of Python, and we have OR for logic OR. Okay, print, and so this is else, and we have colon and print. Okay, so this is a Python logic OR. Okay, we have two values A and B. If A is positive, it's larger than 0, or B larger than 0, at least one is positive. The opposite of this is both are negative. So let's run it. So at least one is positive. Suppose let's use one negative, and we still get at least one is positive because A is positive. So let's make, okay, that's another case had to be 0. Both are negative or 0. Okay, I forgot this one. And you see, and so this is violate, and this is also violate. So both are violate, and then we have both are negative or 0. Okay, so for this case, one is negative, one is 0. Okay, so this is logic OR. Okay, so let's look at the logic no. Okay, so let's assume. Okay, so let's assume A equals 10. So if A equals 10. And so we print, and suppose we print haha. Okay, so this is A. We assume A equals 10, A equals 10, and so we print haha. So let's go to our R. Okay, we print haha. Okay, suppose A is not 10. Suppose A is 9. Okay, A is 9. Then we will not print anything. Okay, then we'll print not anything. Okay, so else. Okay, so let's make it print pass. Suppose we do this way. Okay, so A equals 10, we print something. Okay, then otherwise we print pass. Okay, so this one we print haha because A equals 10, and suppose A equals 0. Obviously we print pass. Okay, so this is we can treat the one as logical yes. Okay, so this is logic no. Okay, so this is if A is not equal 10, then we print haha. Okay, I'm going to compare these two. Okay, so this is first one. This is second one. Okay, so if this one is true, we'll print haha. So this one, so if this is also true, so actually this one is false. Okay, you see it here. If A is not equal 10, we print haha. If A equals 10, we print haha. So this is opposite of this one. Okay, so A equals 10, A equals 10. So this is true. A not equal 10. So this is false. Okay, because A is value 10. A is value 10. So A equal 10 is true. A not equal 10 is false. Okay, suppose A is 9. A is 9. A equal 10. So this is false. A not equal 10. So this is true. Okay, no, logical no is opposite of logic equal.
Shutterstock Music.